Have you ever wondered how we really know if something causes something else? I mean, we see correlations all the time. Think about it. Ice cream sales go up at the same time shark attacks do. But does eating a vanilla cone actually put you in danger? Of course not. Today, we're diving into a massive shift in thinking that helped researchers finally and confidently tell the difference between a simple coincidence and real actual causation. All right, so here's our roadmap. First, we're going to tackle the core puzzle of causality itself. Then we'll look at why the old way of doing things, well, just wasn't cutting it. After that, we'll get into the exciting stuff, the credibility revolution, and the awesome tools it brought us, from perfect experiments to some really clever ways of finding them out in the wild. Okay, so to really get our heads around causality, we have to start with this sort of mind-bending problem that every researcher faces. Basically, we can't look into a parallel universe. Just think about any major choice you've made in your life. Did you go to college? Did you take that job? You know it happened because you made that choice. But what if you hadn't? What would your life look like? That other path? That's what we call the counterfactual. It's the world that could have been. And being able to compare those two worlds, the real and the what if, that is the absolute heart of making a causal claim. And this, right here, this is the dilemma in a nutshell. We only get to observe one reality for any one person. We can see your paycheck after you went to college, but we can never see what your exact paycheck would have been in that other reality where you didn't go. This is what's called the fundamental problem of causal inference. And figuring out how to solve it, that's the holy grail. So for a long, long time, researchers had a go-to tool for this problem, something called multiple regression. The idea was to try and statistically build a comparison group out of thin air. But as we're about to see, that approach was often just an illusion. I'm sure you've heard this 1,000 times in news reports, right? After controlling for income, education, and so on. It's like researchers were trying to tidy up messy data. They thought if they could just statistically account for all the other stuff, the true causal effect they were looking for would be left behind, plain as day. But here's the kicker. As political scientist Cyrus Samai so brilliantly put it, this obsession with controlling for things just led to a flood of what he called pseudo-facts. I mean, they looked scientific, they had lots of numbers, but at the end of the day, they were often just dressed up correlations pretending to be causal truths. So here's why it was so tricky. First, you have to make these, heroic assumptions that you've thought of and included every other possible factor, which is nearly impossible. Worse still, you can fall into this trap of bad control, where you control for something that was actually caused by your treatment. It's like trying to figure out if smoking causes yellow fingers by controlling for whether someone has yellow fingers. And this isn't some tiny obscure problem. We're talking about a huge portion of published research. So as you can imagine, researchers got tired of this. This widespread frustration with the old methods didn't just simmer. It exploded into what's now known as the credibility revolution.
And the big idea, the revolutionary idea, was this. Stop trying to use complicated statistics to fix messy data. Instead, just get better data. The focus shifted entirely to the research design. The new goal was to find or even create situations that looked as much as possible like a genuine, clean experiment.
And this quote right here, this is basically the mantra of the whole revolution. Your claim is only as believable as your design. You just can't make a weak design strong by throwing a bunch of fancy math at it. It all comes back to having a truly solid comparison. Okay, so if design is king, then what's the crown jewel? Well, that brings us to the absolute gold standard for finding causation, the randomized controlled experiment. The power of this is it's so elegant. You take a group of people and then you randomly, like with a coin flip, put them into two groups. Because it's random, the two groups are, on average, identical in every single way imaginable, both the things you can measure and the things you can't. That randomization is the magic ingredient. It solves that fundamental problem we talked about by basically creating a perfect counterfactual for you. And this isn't just for sterile labs. Check out this real-world experiment from Afghanistan in 2013. Researchers wanted to know, does a specific development program actually empower women? So they randomly gave the program to some villages but not others, and what they found was that the women in the program villages showed huge gains. Because of the random design, they could be incredibly confident that the program caused that change. But look, we can't always run an experiment. It might be unethical or just impossible. So what do you do then? Well, this is where researchers got really, really clever. They started hunting for what they call natural experiments, cases where the world, by chance, basically runs an experiment for us. And one of the coolest, most ingenious of these designs is something called the regression discontinuity design, or RDD for short. It's all about finding these arbitrary cutoffs that exist out in the world and using them to our advantage. So here's the logic, the big aha moment. Imagine a scholarship that you only get if you have a 3.5 GPA or higher. Now, think about two students. One has a 3.51 and the other has a 3.49. Are they really that different? No, they're basically identical. But because of that arbitrary cutoff, one gets the scholarship and the other doesn't. Right at that cutoff point, it's as if the scholarship was handed out randomly. We've found our experiment. A fantastic study in Brazil used this exact idea. They wanted to know if being politically connected to the president gets your town more money. So they looked at elections that were decided by a razor-thin margin. They compared the towns where the president's party candidate just barely won to the towns where they just barely lost. Those two sets of towns are practically identical. And what did they find? The politically connected towns got way more money. That's some pretty darn credible evidence. So after going through all of this, from the deep philosophical problem of causality to these super clever designs, what is the one big lesson, the main takeaway from the credibility revolution? It's really this simple. At the end of the day, a strong causal claim comes from a strong research design. A clever design with simple math is infinitely more powerful and more believable than a weak, messy design with even the most complicated statistics you can imagine. So I'll leave you with this thought. The next time you see a headline about some new study, the most important question you can ask isn't, yeah, but what did they control for? The most important question is, what was the design? How did they create their comparison? Where did their evidence actually come from? If you start asking that question, you'll be able to see through the noise and spot the research that really counts. Thanks for joining me.